on the assignments so far. So far we've had 3.11, 3.12, and 3.13.
Oh, when is our test?
After fall break. Now what we're looking at today is more factoring. Now there are some that we call special factors or special type of factoring. Now there's two we're not going to look too close at, and they come, and it would be like this one here, x squared plus 4x plus 4. This is a special type of quadratic that we can factor, but for the most part, we're not going to do anything different than what we've been doing, because we would rewrite it as two sets of parentheses with three spaces. The third term is positive, so the signs are the same and match the sign of the middle term, so plus and plus. Our factors of x squared are x and x. Now the factors of 4 are 1 and 4 or 2 and 2. Here, it is going to be 2 and 2. If we check it here, x times 2 is 2x. 2 times x is also positive 2x, giving us 4x. So that works. But if you notice, both of the factors here are what? X plus 2. So really, we could actually say that this is just x plus 2 squared. This is a special type of factor. We ended up getting a single set of parentheses squared. These are called perfect square trinomials, because we can rewrite it as a single set of parentheses squared. Now they do have a formula that goes along with it that's saying that a squared, well, yeah, ax squared plus bx plus c, and we can actually get to it using two, actually, I'm trying to remember it off the top of my head, because it's ax squared plus 2ab x plus b squared, and we can use this here to get to the factored form. I think it's more work to do that than it is to just factor it. So most of those we don't talk a whole lot about because they work the same way as factoring normal factors. So why not just use those steps and try to break it into A, B, and our terms. Now the one we're looking at, though, I do think is good to look at is this here, our perfect difference of two squares. Difference of two squares. If I have two terms being subtracted and they're perfect squares, I can rewrite it as a term times itself. Something times itself. It's going to come in the form of a minus b times a plus b. Or if we look at this here, so x squared minus 9. X times itself. X times x is x squared. What times itself is 9? Well, 3 and 3. So we can say it's x squared minus 3 squared. So we get x plus 3 and x minus 3. So if we look at this first one here, x squared minus 25. We need to see if these two terms are perfect squares, because if we do have a difference subtracting two terms and they're both perfect squares, they can be rewritten as a number times itself or a term times itself. We do have a difference of perfect squares. Now x squared is, well, x times x. I'm going to rewrite it with parentheses so we can kind of attach it to our a and b terms. Minus, what times itself is 25? 5. So we can say that this is x squared minus 5 squared, a squared minus b squared. And for us here, what's our a relating to? A is just x. B, in our case, is 5. So the general way that a squared minus b squared factors is a plus b times a minus b. And we said a was what? X. And b is 5. So x squared minus 25 factors x plus 5 times x minus 5. That's it. Yeah. If I wanted to check it, x times negative 5 would be negative 5x. 5 times x is positive 5x. And negative 5x plus 5x is 0. Do we have a middle term? Well, no, we had x squared minus 25. There is no term with x, so 0x, 0 is the correct middle term. So the factored form for this here is x plus 5 times x minus 5. That's it. Questions on this here? We ready for the next one? 4z squared minus 1. So again, I'm going to write it here. You don't have to. A squared minus b squared is equal to a plus b times a minus b. Now, if there is a greatest common factor, we notice there is one, we can pull it out. We can factor it out. 4z squared 1, we don't have 1. Now, the first thing we can do is really relate it back to this a squared minus b squared. So I write it in this way with the parentheses really to identify what a and b are. So we need to see what times itself is 4z squared, or what times itself is 4. 2. What times itself is z squared? Well, z. So 2z squared, 2z times 2z would indeed give us 4z squared. It is a perfect square. What times itself is 1? 1. So a in our case is 2z, b is 1. So we would say a plus b. So for us here it would be 2z plus 1. And a minus b would be 2z minus 1. Questions on this here? Are you ready for the next one? X squared minus 64. So what times itself is x squared? X. What times itself is 64? 8. So we have a and b. A is x, b is 8. So we would say that this factors to x plus 8 times x minus 8. That's it. If we're not sure about a number times itself, we can always take the square root, because the square root of 64 is 8. Square root finds what times itself. Questions on these so far? X squared minus 36. I'm trying to give you the answer. So, well, x squared is nice because it's just x times x, or we can say x squared, yes? What times itself is 36? 6. If we need to, we can always grab a calculator and say second square root 36, because when we take the square root of number, we're looking for what times itself is that number. Square root of 36 is indeed 6. So our a plus b would be x plus 6. A minus b would be x minus 6. Questions on this here? We ready for the next one? 100 minus m squared. So this does look a little different, but we're going to still treat it the same. So our first number is 100. So what times itself is 100? 10. And then what times itself is m squared? Well, that'd just be m. Now, just because the variable is not first does not make a difference. We can put it in the second spot. Because our first one would be a plus b, so 10 plus m. And then a minus b, 10 minus m. 10 plus m times 10 minus m. And we can leave it like this here. We don't have to rewrite it so that the variable is first, m plus 10 times negative m plus 10. We can just leave it like this here. Questions on this so far? We're ready for the next one. 9n squared minus 16. So 9n squared would be 3n, and 16 would be 4. So we get 3n plus 4 times 3n. If it's helpful for identifying A and B, go on and identify A and B. If it's not, and you're able to see A and B and go straight to it, do that. (16h squared minus 49). 16h squared, well, we know we would have h as part of A. 16 would be 4. Because 4 times 4 would give us 16, h times h would be our h squared. 49 would be 7. So we get 4h plus 7 times 4h minus 7. Questions on this here? Get ready for the next one. 25b squared minus 36. So 5b squared minus 6 squared. So that'd be 5b plus 6 times 5b minus 6. Questions on any of this so far? Let's add one. Let's say 32x squared minus 32x squared minus 50y squared. You want to factor this. What times itself is 32? So there's not a number times itself that's 32. How about 50? No. So let's look back at it. Is there a greatest common factor between 32 and 50? They're both even numbers, yes? So 2 would have to be a greatest common factor. So I can factor the 2 out. Let's see what's left. If I factor 2 out of 32, we get 16. If I factor 2 out of 50, we get 25, yes? Is there a number times itself that gives us 16? Yes, we've had it, 4. What times itself is 25? 5. So really we can look at this as 4x squared minus 5y squared. We'd have 4x plus 5y and 4x minus 5y. So it is possible to have them still, but we have to take a greatest common factor out. We have to pull something out first. Now, if we pull the greatest common factor out and they still don't reduce, it's not a difference of perfect squares. If we have radicals or have to have roots, for us here, they're not factorable. They can be factored or put in factored form, but we almost have to know the answer to get back to it. Questions on this here? Let's look at this here. So using the difference of perfect square formula, we want to evaluate the given expression. So use the special product pattern to evaluate this here. Well, we know that a squared minus b squared, because that's what they're talking about, is our special product pattern. Factors to a plus b times a minus b. So if I wanted to evaluate 54 squared minus 48 squared, what's a in this case? A would be 54, so we can evaluate this by saying 54 plus b, so 54 plus 48, and we're to multiply it by 54 minus 48. A plus b times a minus b, because a is 54, b is 48. 54 plus 48 would be 102, because 8 and 4 would be 2, carry the 1. 5 and 4 is 9, plus our 1 that we carried would be 102. 54 minus 48 would be 6. And now we just have to do 102 times 6. Which would be 612. Questions on this here? We're ready to look at the next one. All right. 68 minus 62. Go on and set that up, because it's just our a squared minus b squared equals a plus b times a minus b. Yes? Which for us here would be 68 plus 62 times 68 minus 62. 68 plus 62 would be 130. 68 minus 62, incidentally, is still last year. Works out to be 6, 0, 8, we get 780, yes? Bless you. Questions on how we did this here? We ready for the next one? Use the special product pattern for 36 squared minus 34 squared. 36. And that would be 140. Yeah, these are nice. Doing this here is nice if you don't have a calculator. Because if we tried to do this in the normal method, especially 47 squared, I'm going to have to multiply 47 by itself. 9 carry the 4, 28, 32. 0, 8 carry the 2, 16, 18, 9, 0, which would be 2,209. Have to do the same thing with 44. Carry the 1, 17, 0, 1, 6, 2, 1926. Then we would actually subtract these here. It's 3, 8, and should get 383. Because again, if we're doing all this by hand, that is a lot of work to try to get to the answer. Where according to this method, I could just say that we have 47 plus 44 times 47 minus 44. Well, 47 plus 44 would be 91. 47 minus 44 is 30. That's a lot easier, a lot faster than trying to square both of them and do that there. Or if we have a calculator, it'll do it for us. Questions on this here? That's it. Y'all should be able to finish this entire assignment for lunch. Four.